Okay, hey guys. I have a kind of a sick kiddo at home, I guess. I don't know. She threw up this morning, but she's been running around like crazy ever since. So that's where I'm at. But we're gonna combine two sections today, just to get them done. They're both volume. And so you need to have this sheet of paper with you that has all the formulas for it just in one spot. And then you need 11.6, and then we'll go to 11.7 and do a couple of examples. So I'm going to kind of pick and choose and skip through here. You'll have just like a few homework problems from each section, but I'm going to combine them into one. So let's start off with like going over the volume formulas just so you're familiar with these. And the first one, like they start us off with prism. Okay, so volume formula is way smaller than what the surface area formula is for a prism. Let me go to the right thing here. And volume, they have capital BH, okay? Capital B means the area of the base. So I'm going to write that in here. Area of the base, okay? So what that means is like here, this is a rectangular prism. We'll talk about a triangular prism here in a second, but rectangular prism, the base here is a rectangle, okay? So let's say we have 5 by 3 by 4. I have no idea what our units were before, but if I'm trying to find the area of the base, that's the area of this rectangle here, and the area of a rectangle is just base times height. So it's like 5 by 3 is how I find the area of the base. Then the height is 4, okay? Now, you might have already known that it's just like length times width times height, and that's essentially what the area formula or volume formula is for a prism, okay? If, let's say, by chance you have a triangular prism, so let me like, I don't know, something like that, right? Okay, let's say you have that going on, right? And let's say this is a right angle, okay? And this is 5 by 4, and then this is 3, right? Let's say that you have that, okay? In that case, the bases are going to be these two triangles, and to find the area of a triangle, you'll do half base times height, right? So I do 1/2 times 5 times 4, so that would be 10, and 10 times 3. So in that case, the area of the base right here would be 10, and the height would be 3, so 30 would be that guy's volume. Okay, this one's volume, 5 by 3 is 15, times 4 is 60. So that is 60, and the units are cubed. Okay, every volume is cubic units. Okay, now, pyramid is very, very similar to a prism. It's just a third, right? So whatever units I have for a prism, let's say I have the same units for the pyramid, right? It would have to be a 5 by 3 by 4, right, in order for this to work. But if I have those same units, this guy's volume will be a third of this guy's volume. Okay, I'm going to change the numbers here, though, just because why not? And let's say that this is a square prism, right? Or square pyramid, I mean. And let's say this is 4 by 4. Actually, you know what? Let's go different. Let's go 6 by 6, right? And let's say that the slanted height is 5, right? This is the slanted height, okay? So now if I like drive a pole down the center here and I look at this, I have this thing going on where this is 5. This length here is 3, right? Because it's half. It would be like this distance, okay? That would be 3. So that would mean that this center right here, if you do the Pythagorean theorem, is 4, okay? So we've got to look here and we've got to see for the volume formula. I know it's a third. And capital B is the area of the base, okay? The area of the base is the area of this little square right here, and that's a 6 by 6, and so that would be 36, okay? And the height is the regular height. That's like this height right here, not the slanted height. That's this height right here, and that is 4, okay? So I know that a third of 36 is 12, and 12 times 4 is 48, so that's 48 units cubed is what that is, okay? So that's how that works. This is a third of this one, okay? Now, it's actually the same thing for a cylinder and a cone, okay? This one is a third of this one, okay? So let's say this cylinder right here has a radius of, I don't know, we'll say 10. Has a radius of 10 and a height of 8. I don't know, okay? Not drawn to scale because that would be a really fat cylinder, but whatever, we don't care. So we take pi times the radius, which is 10, squared times the height, okay? I know that 10 squared is 100, and 100 times 8 is 800, so this will be 800 pi, and then you can multiply that out, whatever it is. I'm not going to go ahead and do that, but remember that that's in units cubed. So 800 pi. This guy, let's say that my radius was still 10 and my height was still 8. Now, not the slant height, the regular height. I would have to be 8, okay? If that's the case, then this will end up being the same dimensions as before. It's just that it will end up being a third, right? So 800 pi, instead of it being 800 pi, it's a third of that, so it would be 800 over 3 pi, right? Or 800 pi over 3, which is like, I don't know, what's 800 divided by 3? 2 and 2/3, something like that. So 267 pi, something like that, whatever, units cubed. Okay, volume of a sphere, though, is really disgusting. 4/3 pi radius cubed. So let's say the radius here is, I don't know. Let's go 4. I don't know. Okay, I'm just going to plop 4 in for my radius here. 4 cubed is 64. And all you do for this is when it says 4/3, I'm going to take 64 times 4 divided by 3. And then slap a pi on the end of it, right? Whatever that ends up being. Let me grab a calculator. 64 times 4 divided by 3 ends up being 85.3 pi. And you can multiply the pi through if you want, but that's in units cubed. Okay, that's volume of a sphere. Okay, all right, so those are the formulas. Again, a cone is a third of a cylinder, a pyramid is a third of a prism, and then a sphere is just weird. Well, yeah, I don't know. That's not even a third or anything. So anyway, so those are your formulas. Make sure you have this sheet of paper so that you can go through stuff. And I'm going to skip around here. I was going to do, should we do example 2? Now, let's skip to example 3, okay? We'll go to example 3. So I'm on 11.6, and I'm going to do a couple more examples. This is example 3 on 11.6. This one says they want us to find the volume of this box right here, right? Well, this is a rectangular prism. Okay, prism. And volume for a rectangular prism is capital BH, right? Capital B is the area of the base, and the base right here is this guy, okay? If I'm trying to find the area of that rectangle, it's just this base times height, right? So to find this capital B, that will be 4x times the other x, right? And then the height is 4x plus 3, okay? All right, so they want us to go ahead and probably solve this out, right? I'm just taking the 3 dimensions times each other. 4x times x is 4x cubed, okay? And if I'm going to take that times this guy, I just distribute him through, okay? So 4x cubed times 4x is 16x to the 4th, and 4x cubed times 3 is 12x cubed. So I'm just going to write my volume as that, okay? And for a couple of your homework problems, they're just going to ask for that. It says find the area of the base. Or no, find the area of the base, find the volume. Find the volume. Yeah, they say just find the volume. There's going to be like a part A where you find the volume in terms of just x, right? So this is what they want for part A on a lot of your homework problems. But then they say, okay, go ahead and find the volume if x is 2. So we're going to plug that in. 16 times 2 to the 4th plus 12 times 2 to the 3rd. And we end up getting a big, huge number, right? 2 to the 4th power is 16, and 16 times 16 is 256, plus 2 cubed is 8, and 8 times 12 is 96. I'm going to add those together, so I don't know, 352 if I did that right. And that is in inches. I have to go back to the original. That is in inches cubed. If x was 2. So this would be like a 2 by 8 by 11 if x was 2, right? And then that would be the volume. So 2 times 8 times 11 should end up being 252, I'm going to guess. Okay, so they're going to ask you just write it out in terms of x and then actually plug a number in. Okay, all right, so there is that. Let's go to volume of a pyramid. Okay, pyramid volume is 1/3 capital B times H. Okay, and so they're assuming that this is a square pyramid, is what I'm guessing. Ugh, this is disgusting. I don't want to do this. Yeah, because our height is not 5x. Our slant height is 5x. That's not good. That's not what we want. Shoot. Oh no, that's going to be fine. That's going to be fine. That's going to be all right. Okay, so here's what we've got going on here. All right, so we have to have 1/3 capital B times H, right? Capital B is the area of the base, and the base is this guy right here, which is a square, okay? And if this is 8x, then this is also 8x. And so I'm going to multiply those together to get the area of my base, and 8x times 8x is going to be 64x squared. Okay, now I have to find the height, and this is the kicker right here. The height is this height, okay? But if I look at this as a triangle, right? Okay, don't get intimidated by this. I was just a little confused just now, but it's not going to be that bad, right? This slant height is 5x. This base right here is not 8x. That's 4x, right? So then what's this height? It's 3x. It's just a 3, 4, 5, right? So the height is 3x, right? So now I'm looking at this guy being the volume, all right? And I see some things that I can put together, like a third of 3. Those can just cancel out, right? So I've got 64x squared and x, so that's 64x cubed is what the volume is. Okay, now they're probably going to have me plug a number in. They're going to say, what is it if x is actually 4? 64 times 4 cubed. I know that 4 cubed is 64, so it's basically like 64 by 64. And we end up with 64 times 64. And that is 4096. And that is in the units of inches cubed, cubic inches. So there is that. Okay. All right, let's go on down and see if we can find something else. That was, I think that's all the examples that I have. We did an example of a cylinder, a prism, and a pyramid. That was all for 11.6. Okay. So here's what I want you to do. I'm going to go down and do some 11.7 examples, but this is what I have planned for homework for 11.6. So it is 2, 8, 10, and 12, just those 4 numbers for 11.6. But I'm going to add like 4 more problems or 5 more problems, something like that, on 11.7 to this. So rip this page out, write those at the top, and then we're going to go do some examples on 11.7, and we're going to call it good, okay? 11.7 is cylinders, cones, and spheres, right? Cylinders, cones, spheres. And we just talked about this formula, so I'm not going to go over those again, but here is another example. The thing that I will caution you on, the reason why I circled this example was this. It says that, let's see, 1.25. See, I don't like the way that this is labeled because we don't know. Andrew wants to mail his brother a collection of antique marbles. He needs to calculate the volume of the mail before he buys it to ensure that it will hold all of the marbles. Okay, they did not label this very well because it looks to me like 1.25 is the diameter, in which case we will have to split that in half to find the radius. But if I go down here to the formula, they did say the radius was 1.25. So I do not like how that was labeled. That is what I will caution you on. When you go to do these homework problems, make sure that if they're giving you the diameter that you actually use the radius. All right, volume of a cylinder is pi r squared times the height. Now, just for those of you who like these formulas make sense to, pi r squared is the area of a circle, right? Area of a circle. So they're just basically finding the area of this and then just filling it in using the height, okay? Because the volume of a cylinder, or volume of a prism, was capital B times H. Capital B was the area of the base, right? Well, that actually holds true for a cylinder as well. It's just that the area of the base is a circle, and then you're multiplying by the height, okay? So whatever. All right, so we got pi times the radius, which is 1.25, they say, I guess, times the height, which is 10, and they, when you multiply that out, they ended up, I'm just going to cheat and use theirs, 49.1 inches cubed. No, don't forget to put your label on the end. It needs to be in inches cubed, okay? Not too bad, right? Okay, let's go down and do, I'm hopping over to example 3 because this is volume of a cone, okay? So cone is going to be 1/3 pi r squared h, right? Okay, or they say 1/3 capital BH, but it just so happens that their capital B is the area of the circle, right? Okay, so kind of the same thing. I've got 1/3 pi, the radius of this. They have it labeled as x minus 1. X minus 1 squared times the height, which is 3x minus 5, okay? And I think, yep, they say, so the volume of the cone, they just want you to find the volume of the cone in terms of x and in terms of pi. That means leave the x's as they are, leave the pi's as they are. So this is the answer for the volume. Okay, that's usually on your homework assignment, that will be part A. Okay, but part B, we got to plug something in. So they say find the volume if x is 4. Okay, that's it. We just plug 4 in. okay? So this is 1/3 pi times 4 minus 1 is 3, and 3 squared is 9, so I'm just going to plug 9 in there. 3 times 4 is 12, minus 5 is 7, okay? Now, I can simplify some things. 1/3 of 9 is 3, and 3 times 7 is 21, and so 21 pi is the answer for the volume, or if we multiply it out, 21 pi, we get 65.97. Do at least one decimal place. I went ahead and did 2 on that one because I had already written the 5 down, and the 7 would have bumped the 9 up, and so it would have been 66.0 if we would have done one decimal place. Whatever. Do at least one decimal, so either one of those answers I will take. Oh, and not feet squared, feet cubed, because that is volume, okay? So don't get intimidated by these like X's and stuff in there. Just write the formula in there and then plug the number in that they want you to, okay? All right, last one is a sphere. I'm going to go down to example 5, and this should just be fairly short and sweet. Volume is 4/3 pi radius cubed. I challenge some of you who are very fluent with these formulas to start kind of at least memorizing a little bit, or at least like what the formulas kind of entail. So that's kind of my challenge to you, is to start doing that. All right, I'm skipping in the middle paragraph because I see this word right here. If the diameter is 1.5 inches. Okay, the only thing we need is the radius, but the radius is not 1.5, the diameter is 1.5. That means the radius is 0.75, okay? So we're gonna plop him in there, 0.75, and, oh man, that's a lot. I'm just gonna write it out, 4/3 pi. Ooh, I'm sitting outside, and you guys can probably hear the wind, sorry. Okay, 0.75 cubed, okay, is a number. So I did this part first, and then I'm going to take that times 4 divided by 3, because that's how I do this 4/3. Or if you have a calculator that will do the fractions, you can so do that. That is 0.5625, but I need the pi in there, so I'm going to multiply by pi. And I end up getting 1.76, or 1.77 actually. And that is in inches cubed. That's really small for a thing, but you guys know what they're talking about. They're talking about this little circle thing, 1.77 cubic inches. Yeah, so like a cubic inch would be like an inch by an inch by an inch, right? Like tall, wide, whatever. You get the idea. Oh, this is not turning out the way that I wanted to. But 1 inch by 1 inch, that would be 1 cubic inch. So this is almost 2 cubic inches. So it's a decent sized little chocolate circle, whatever. Okay, so there you go. There's some examples of spheres, cones, cylinders, prisms, pyramids, all the things, right? Let's go and do for homework these 5 on page 687, 2, 4, 8, 10, 14. Add those. You can rip this out because I think this is just a 1-pager. There's some on the back side. But rip this out and you can staple 11.6 and 11.7 together. I just kind of wanted to combine those because for 1, we're running out of days, and for 2, they're both volume, so, and they kind of both make sense. So add those. That's 9 homework problems, and there you go. Have those ready for tomorrow. Tomorrow we start our semester review packet, so make sure that you've got everything ready to go to begin that tomorrow. All right, goodbye.